Okay, in this video I'm going to talk about what are called linear inequalities, but specifically compound inequalities. And just like the word compound implies, they are two simple inequalities that are joined either by an and or an or. Now let me show you what that might mean. Like here for an example is an and kind of a statement. 3x minus 9 is less than or equal to 12, and let me see, 3x minus 9 might be greater than or equal to negative 3. Now with a and statement like this, you're probably going to have what's called an intersection between the two inequalities. All right, so let me write that down there. You're going to have something called an intersection between the two inequalities. That means that they're going to overlap one another when you actually graph them on a number line. Now let me show you how that works. I'm going to solve each one of these individually, right? So I'm going to add 9 to both sides here. I'm going to get 3x is less than or equal to 21. Then I'm going to divide by 3, and I'm going to come up with x is less than or equal to 7. Okay? Put that on a number line. There's my 0. Now when I'm sketching these, I really don't have to do all the little slash marks. I'm just going to go like right about here and pretend that that's 7. It's less than or equal to, so I'm going to have a filled in dot, and less than follows the direction of the arrow in that way, okay? Let me solve this one. Add 9 to both sides. I get 3x is greater than or equal to, adding 9 here makes that a positive 6. Divide by 3. I get x is greater than or equal to 2, okay? Now I'm going to go right here for my 2. Again, it's going to be equal to, so I'm going to put a full circle there filled in, and I'm going to follow the direction of the arrow. Let's go that direction. Now the and means intersect, right? So where the two answers overlap one another is my answer. And then I'm going to write this in interval notation. And remember that you always start at the left hand of the answer. You write down the farthest edge, which would be 2. You put a comma, and then you go to the farthest right edge, and I would put a 7. And then I would decide whether to use brackets or parentheses. Now, since this is actually starting and including 2, it's a bracket. Since this end is starting and including 7, it's another bracket. And this would be a compound inequality answer that would work in both of my original inequalities. Let's just take a number. Now I know between 2 and 7, let's just take 5. 3 times 5 is 15 minus 9 is 6. 6 is indeed less than or equal to 12, so that one's good. Let's put that same 5 over here on this side and see if it works. 3 times 5 again is 15 minus 9 is 6. And 6 is indeed greater than or equal to negative 3. So this answer, the shaded area right here, this compound inequality written in interval notation, would satisfy both of these equations. All right? And that's called an and statement or an intersection. Now, what about an or statement? Let me show you an example there. Okay? Now, actually, before I get up there, or usually implies a union of two different answers that don't overlap one another, okay? Here's an example. Let's say I have the equation 3x minus 9 is greater than or equal to 12, or 3x minus 9 is less than or equal to negative 3. Now watch what happens. I just used basically the exact same ones up here, right? But I changed the answers and I flipped the inequality. Look what happens when I solve these. Again, add 9 to both sides. 3x is greater than or equal to 21. Divide by 3. X is greater than or equal to 7. Go ahead and put my number line. Pretend that's 7. Fill it in again at the 7 because it's equal to, but now I am greater than, so I'm going in that direction. Here, let's add 9 again. 3x is less than or equal to positive 6. Divide by 3. X is less than or equal to 2. Let me go to 2. Fill it in. Go in the direction. Now see what happens here. There is no overlap. There is no intersection between the two answers. So what I have to do is write each one of these using interval notation. Negative infinity in the far left. Goes all the way up to 2. This has an open end because it keeps on going, so I use a parentheses. This one has a closed end, so I use a bracket. This graph here starts at 7. The far right is an open infinity. Since it closed here, I can put a bracket. And since this side continues, I'm going to put a parentheses. Now, instead of putting, actually what I put for union or is just the letter U, or this symbol. It's not really a letter U, it's just called the union. So this means I would read this as these answers would work, or these answers would work for both of these inequalities. Now let's see if that's actually true. Let's just choose a number that's less than 2, like 0, for example, okay? 3 times 0 is 0, minus 9 is negative 9, right? Greater than or equal to 12, no, but 3 times 0 is 0, minus 9, negative 9 less than or equal to negative 3, yes. So it actually works for one of the two inequalities, right? Let me just see. Or. So that's why you put your or statement in. Did I say that right? Let me just check just to make sure. Yeah, I added 9. Yep, got 21. Divided by 3. Yep, got 7. Made that means that was greater than here, right? So that 0, right, would not work in this one, but it does work in that one. Right? So that's why I had to use both of these answers. And that's why I put the union of the two. So I hope that was helpful. So again, the thing to remember is that compound inequalities are simply two simple ones that are joined together by the word and or or. And implies that there's an intersection, a common answer that works in both. Or union means that one or the other of the inequalities will fit and satisfy one of those, okay? So I hope that was helpful.